long recording of this stuff. All right, so back to the circle here, we're going to try to find the y-intercept. So back to my piece of paper where I drew this out. And again, super important to survive this class, you're going to have to draw pictures often. So have a notebook ready and be sketching stuff out. Okay, so I want to find the y-intercept here and a y-intercept here. So now suppose my instructions were to find the y-intercept or y-intercepts. All right, let's see. What do I know about y-intercepts? I know that y-intercepts live on the y-axis. Okay, if I'm on the y-axis, then I haven't gone left or right. So that means x has to be 0. So if you're looking for y-intercepts, the important fact is x is 0. So all I have to do is go to my equation up here and let x equal 0. All right, let's do that. So I plug in 0 minus 2 squared plus parentheses y minus 3 squared equals 25. And then I do my best to solve that. So let's bring that to a new screen where I have a little bit of space. Let's see, new page. So we are looking for y-intercepts again. So my zoom is in the way. Intercepts, there we go. And y-intercept means that x is 0, x. And so in my equation for the circle, I just plopped in a 0 there. And there are many ways to solve an equation. Pretty much any equation that's not super simple, like x plus 2 equals 3, is going to have many ways to do it. So I'm going to show you how I would do this. First, I would look at this and say, well, order of operation wise, I guess I just do what's inside the parentheses. 0 minus 2 is negative 2. And if I square negative 2, I get positive 4. Y minus 3, well, order of operation wise, I don't know why, so I can't do anything inside. So I'm stuck with the y minus 3 at the moment, and I'm stuck with the square equals 25. From here, there's 2 routes you could take. You could square the y minus 3. So that's one possibility. Y minus 3 squared really means y minus 3 times y minus 3. Don't forget that. That's super important. And then you have to distribute. Y times y is y squared. Y times minus 3 is negative 3y. Then we have to move to that guy. Negative 3 times y is negative 3y. And then negative 3 times negative 3 is positive 9. So that squares out to be y squared minus 6y plus 9. And then you can put that back in here. It turns out in this case, that's the hard way. It works, but it's the hard way. What's way easier here, just subtract the 4 over to the other side. The only way to know that's the hard way is to do both ways and see, oh, wow, that was way harder. I happen to be gifted with a fair amount of experience, which sometimes helps. Now, since I just have the square alone on this side, I can just take the square root. I don't have to square it out. So I'm going to take the square root. And I have to remember a very important trick here. If you want the square root and the square to cancel, you have to adjust the other side with a plus or minus. And that's a commonly forgotten thing there. So now I know that y minus 3 equals plus or minus 21. And then I'm going to add that 3 over. And so I get y is equal to 3 plus or minus square root of 21, which really is 2 answers, right? It's y equals 3 plus the square root of 21 or 3 minus the square root of 21. If you had gone with the hard way here, which, hey, if you're bored later, go for it, you would have had to use the Pythagorean theorem, the quadratic formula, probably, because this would have been unfactorable because of the square root in the end. So ultimately, this would have led to the quadratic formula or completing the square. And I think I actually will take a look at that in just a moment, but let's check out, did this happen right? So on tests, most of the time I'm going to give you a calculator, so you could just check that these worked on your calculator. So let's go over to our calculator and check it out. All right, so here I am in my Desmos calculator, and Desmos said that this y value excuse me, was 7.583. I think now that value is actually 3 plus, you can get the square root symbol down here, 21. And there is my 7.58. You can round that to 7.583, like this said right there. So does my calculation confirm what the screen told me? Yes, but now I have an exact answer. And how do I mute my phone? Oh, I don't know how to mute my phone. Sorry about that. My office phone has too many buttons. Is that muted? Yeah, there we go. All right, so we found the exact answer. So just a note back in my notebook. These answers right here are exact, and sometimes you'll be asked for exact answers for your homework. But I could approximate them by plugging this into my calculator. That this one right here was about 7.583. And then the other one, calculator, would be 3 minus the square root of 21. Oh, by the way, another trick on a computer, if I'm feeling too lazy to use that toolbar down there, if you just type SQRT in a lot of math programs, they'll automatically say, oh, that's the square root. I'll make a note of that in the notebook. So let's see, anyway, negative 1.583 was the other one. And these answers are approximate to the nearest 10th, 100,000th. On paper, when I'm trying to tell somebody I had to round, I'll usually write something like this, that 3 plus the square root of 21 is wavy equal sign means approximate 7.583. Okay, so when you round something on paper, we designate that we rounded by just putting that wavy equal sign in there to say, hey, this is about the answer, but it's not exactly the answer, just close enough for now. All right, let's take a look at the quadratic formula and completing the square next. There will be a couple of homework problems where that will come in handy.